definition statement I is equals to V by R. Have you heard this?
Yeah. Current.
Yeah, Ohm's law. I is equals to V by R. What is the meaning? I means what? Where I is what? Current.
Current.
Correct.
Current.
I is current. V is voltage. R is resistance. See, look at this. Here you can see one formula. Can you see it now? I is equals to V by R.
Yes, sir.
What is the meaning? How do you define it? I means what? Current. Current flowing through a conductor. Where it is flowing? Current is flowing through a conductor is directly proportional to voltage. Here in the numerator you can see voltage. Correct? Voltage.
Yes, sir.
Here you can see V and I are directly proportional. Yes or no?
Yes,
V
sir.
is proportional to I. It means what? As the voltage increases, current also increases. Correct?
Yes, sir.
That means what? Directly proportional. Inversely proportional means what? One parameter. If one parameter is increasing, corresponding another parameter will be decreasing.
Yes.
Here, I and R both are I and R both are inversely proportional.
Yes, sir.
Where is R? R is in denominator. Yes or no? See, compare this first one and second equation. I and R both are exchanged. Yes or no? Here
Yes,
I
sir.
is there, here R is there. Here you can cross multiply, take this R at the left side. I can be transferred to denominator. It means what? As R is increasing, current is decreasing. Due to increase in resistance that results decrease in current. Yes or no?
Yes, sir.
As current increases because of decrease in resistance. Due to decrease in resistance, current increases. This means what? Inversely proportional. Okay. Next, how do you define Ohm's law? Means with the help of this statement, I is equals to V by R. How do you define I? I is what? Current. Current flowing in a conductor is directly proportional to the voltage across ends of the conductor. Voltage across ends of the conductor. Directly proportional to voltage and inversely proportional to the resistance. This is the statement for Ohm's law. Simple. What is the statement? I is equals to V by R is the expression. Statement is current flowing through a conductor is directly proportional to voltage across ends of the conductor and inversely proportional to the resistance. Clear? No? Statement is clear.
Yes, sir.
Okay. With the help of one example, we can try to understand this. Let us consider V value 10 volts is given. Voltage is how much voltage is given? 10 volt. Resistance. How much resistance is given? 5 ohm. Voltage is measured in terms of what is the unit to measure the voltage? Volts. Voltage is measured in terms of volts. Current is measured in terms of amperes. Okay. Resistance is measured in terms of ohm. This is the symbol ohm, OHM. Okay. R is equals to 5 ohm. Consider voltage as 10 volt, resistance as 5 ohm. If we have these two values, we can easily find the current. We know the formula I is equals to V by R. Substitute V and R. Given V and R. Substitute here I is equals to V value is 10 volt. Substitute here in the numerator. Resistance in the denominator, that is 5 ohm. 10 by 5 is 2 amps. This is very simple. Okay, Ohm's law is very simple. Any confusion?
No, sir.
Okay. See, here it is clear. Which one? Ohm's law is clear. Now the question is, why the KVL and KCL? Have you heard KVL and KCL?
Yeah, Kirchhoff's voltage and current.
Kirchhoff's voltage law and Kirchhoff's current law. These two. Why these two are implemented? That is the question. Because there are some limitations in Ohm's law. In Ohm's law, there are some limitations. To overcome those limitations, Kirchhoff's voltage law and Kirchhoff's current law was introduced. Okay. What was that limitation? What was the drawback of Ohm's law? We cannot say it as a drawback, but we can say it as a limitation. There was some limitation. What is that? We cannot apply Ohm's law for complicated circuits. Ohm's law is applicable only for simple circuits. Ohm's law is applicable only for simple circuits. Now we'll try to understand what is the meaning of simple circuit and complicated circuit. What I said, what is the limitation of Ohm's law? What is the limitation of Ohm's law? Ohm's law cannot be applicable for complicated circuit. I said Ohm's law is applicable only for simple circuit. Simple circuit means what? There will be one resistance, either current source or voltage source. Okay, there is one resistance, single resistance. See, look at this circuit. Let me consider this circuit. Can you see this circuit?
Yes,
in
sir.
this circuit, what are the different things you can able to see here? Here 8 ohm resistor is there, here 3 ohm resistor is there, here 6 ohm resistor is there. How many resistors are there? 3 resistors are there. How many voltage sources? How many sources are there? Yes, single one source is there. What type of source it is? Voltage source. Source means what? What is the meaning of source? Source means what? What is the meaning of source?
Source may be like voltage current.
Voltage current. To operate this circuit, something is required, no? Some energy is required, right?
Yes, sir.
To operate this circuit, some energy is required, some power is required. Either voltage or current is required to run this circuit. Yes or no? Source. Two types, voltage source, current source. Here voltage source is there in this circuit. Okay. Look at this. As I said, if there is a single source and single resistance, then we can easily apply the Ohm's law. What I said, if there is a single source and single resistance, that's very easy to apply Ohm's law. Yes, sir. But in this circuit, how many loops you can see? How many loops are there? What is the meaning of loop? Loop means what? Closed path. Closed path. Here in this circuit, how many loops are there?
2 loops.
2 loops. Here left side one loop is there. L1 and L2 is named as L1 and L2. 2 loops are there. Okay. If someone is asking like how much amount of current is flowing through 3 ohm resistance, how much current is flowing through 8 ohm resistance, how much amount of current is flowing through 6 ohm resistors, how do you find? With the help of Ohm's law, is that enough? With the help
No,
of
sir.
Ohm's law, can I able to find the current flowing through one particular resistance? No.
No.
If the circuit is having single resistance, single source, do we have single resistance and single source here? No. In this circuit, we have 3 different resistors, 2 loops, single voltage source. Yes or no? It means what?
Yes, sir.
This circuit is somewhat complicated circuit, not a simple circuit. Simple circuit is different, complicated circuit is different. Ohm's law can be applied only on simple circuit. If there is only one source and only one resistance, then we can apply Ohm's law. Cleared?
Sir.
With the help of KVL and KCL, we can overcome the problems in Ohm's law. What was the problem? Current flowing through 8 ohm, 3 ohm, 6 ohm. Each and everything we can find out with the help of KVL and KCL. Okay. Now we'll try to understand what is the meaning of KVL and KCL. What is KVL?
Voltage law.
Yes, Kirchhoff's voltage law. KCL is what? Kirchhoff's current law. One is voltage law, one is current law. Proposed by Kirchhoff's, name of scientist. Okay, Kirchhoff's voltage law and Kirchhoff's current law. First, we'll try to understand what is the meaning of Kirchhoff's current law. Kirchhoff's current law. What it states?
Entering through the is equal voltage and entering is equal to voltage leaving to the junction.
Yes.
Like that.
No, not voltage. Current. I'm talking about current. Okay. KCL
Yes,
means what? Current. Only KCL. Let me discuss. Only KCL. KCL images. Yes. This one. Can you see it now?
Yes, sir.
Look at this. What is there here? Here center one node is there. Okay, that connects how many branches? Here this vertical line is carrying which current? I1. That current is named as I1. Here I2. Here I3. Here I4. This one is I5. Total how many currents are there?
5.
Yes, 5 currents are there. But all 5 currents are entering into this node or leaving from the node. Few of them are entering into the node, remaining leaving from the node, going out. Okay, moving out from the node. Yes or no?
Yes, sir.
Here you can see I1, I2, I3. These three are entering into this node. In this center node, I1, I2, and I3 are entering, incoming to this node. Yes or no?
Yes, sir.
But I4 and I5 are moving out, exiting, outgoing from this node. Yes or no? I4 and I5 are outgoing currents. Correct?
Yes, sir.
Now come to conclusion. What is the statement for KCL is algebraic sum of all the currents. What I said? Algebraic sum of all the currents meeting at a junction point. Junction point means this one. In this junction point, whatever the number of currents are incoming or outgoing, you just add all those. Summation of all the currents meeting at a junction point taken with the proper sign is equals to 0. At last, what I said? Taken with the proper sign. It means what? As I said already, few of them are entering into node. If the current is entering, consider it as a plus. If the current is outgoing, consider it as a minus. How many currents are going outside? Outgoing currents. Out of 5 currents, I4 and I5 are outgoing. Yes or no?
Yes.
I1, I2, I3 are incoming to this node. So let us consider incoming currents as a plus. Plus I1, plus I2, plus I3. Okay, outgoing currents I4 and I5. Consider these two as a minus I4, minus I5. Okay, as per the statement of KCL, algebraic sum of all the currents means we have to add all the currents. What are the different currents we need to add? I1 plus I2 plus I3 plus I4 is outgoing. No, that's why instead of plus, consider minus. Minus I4. Similarly, I5 is also outgoing. consider minus. Plus into minus, minus I5 equals to 0. Whatever the minus currents are there, minus I4 and minus I5, transfer at right side. Initially, they are at the left side. Transfer these two, I4 and I5, right side. It means what? I1 plus I2 plus I3 equals to I4 plus I5. Yes or no? After simplification, in the next step, what you can see, I1 plus I2 plus I3 is equals to symbol, right side, I4 plus I5. What are I4 and I5? Outgoing currents, sum of outgoing currents. What are I1, I2, I3? Incoming to the node, incoming current. Sum of incoming currents is equals to sum of outgoing currents. Cleared?
Yes, sir.
You can define KCL in two ways. What is first way? Algebraic sum of all the currents meeting at a junction point taken with proper sign is equals to 0. With the help of pictorial representation, diagrammatic representation, we can draw this diagram. Few currents are entering to the node, I1, I2, I3 as per this diagram. I4 and I5 are outgoing from the node. Let us consider if the current is incoming, consider as positive. If the current is outgoing, consider as negative. Sum of all the currents means I1 plus I2 plus I3 plus I4 plus I5 actually. But I4 and I5 are outgoing, no? Consider these two as minus I4 and minus I5 equals to 0. After simplification, transfer these two minus currents at right side. Okay, left side I1 plus I2 plus I3 equals to I4 plus I5. What are the currents at left side? Incoming currents, sum of incoming currents. What are the currents at right side? Outgoing currents, I4 and I5, sum of outgoing currents. Sum of incoming currents is equals to sum of outgoing currents. That is what KCL. Cleared? KCL is cleared.
Yes, sir.
Similarly, KVL, Kirchhoff's voltage law. What did I say? Kirchhoff's current law means what I said? Algebraic sum of all the currents, I said. In KVL, algebraic sum of all the voltages. Yes.
Yes, sir.
KCL means algebraic sum of all the currents. KVL means algebraic sum of all the voltages. Simple, no?
Yes, sir.
Where we need to apply KCL? Whenever we see a node here, junction point you can see, no? Whenever we see a node, we can apply KCL. At node, we can apply KCL. Where we need to apply KVL? In loops. See, let us consider this circuit. How many loops are there in this circuit?
3.
3 loops. Yes, 3 loops. 3 loops are there. How many currents are flowing through this? How many currents? Here we can find current flowing in first loop, that is called as I1. Current flowing through this second loop, that is called as I2. Current flowing through this third loop, that is called I3. I1, I2, I3. To find these 3 loops, loop currents, we need to apply what? KVL. To find the loop currents, we need to apply KVL. Okay, what is KVL? Algebraic sum of all the voltages. What is KCL? I said algebraic sum of all the currents. KCL means algebraic sum of all the currents. KVL is algebraic sum of all the voltages. It is something like V1 plus V2 plus V3 plus so on equals to 0. Just like KCL, I1 plus I2 plus I3 plus I4 so on equals to 0. In KVL, it is something like V1 plus V2 plus V3 plus up to so on to Vn equals to 0. N number of voltages add them equals to 0. That is what? KVL. Clear, no?
Yes, sir.